Hi everybody, this is Arthur with Dasha AI. In case you're tuning in for the first time, Dasha is a conversational AI as a service platform for developers, so any developer can start building fully human-like, deeply conversational experiences which are powered by AI. But you don't have to know a single thing about AI or machine learning. Those all come as a service of the Dasha Cloud platform. All the code you build with Dasha actually belongs to you. It's your intellectual property, which really opens up a bunch of possibilities. So today I'm going to show you how to build a pretty simple customer service automation app. So imagine you've got an insurance call center and you want to build an AI agent that will pick up a phone call, ask the customer for their policy number, answer a few of their questions, and then ask for some feedback at the close of the conversation. That's exactly what we'll build today. To get started building with Dasha, the first thing you should do definitely is join our community, and I've got a link to that in the description to the video. You will get instructions on how to obtain your Dasha API key and to launch your first test conversation. If you've got the latest versions of Node.js, NPM, and Visual Studio Code installed, that whole process is going to take you maybe like, I don't know, 5 minutes, probably less. Excuse me. So the second thing you'll want to do is to download the Blank Slate app, and I've got it linked to the GitHub repository in the description as well. So download the app, open it up in your Visual Studio Code. I've got it opened up here already. There are 4 main files that we will be working with, and package.json is not one of them. So in package.json you may want to change the name of the app, but the ones that you'll want to open up are index.js, main.dsl, phrasemap.json, and data.json. So let's start with index.js. This is the JavaScript file which gets executed and which loads up the Dasha SDK and lets you basically load the Dasha SDK into your application, and the SDK connects your Dasha application to the Dasha Cloud platform to execute the conversation. So this is where we load up the app, the Dasha app, and we will be referring back to this file because we will be building some additional functions in it, what we call external functions, functions that get called upon from the body of main.dsl Dasha scripting language file. So main.dsl is the basic building structure of your conversational app. Like, this is the conversation. It's the file we'll be working with a lot. And second file we'll be working with quite a bit is phrasemap.json. So this is a file which defines the phrases that you want your agent, your AI, your automated agent pronouncing as you go along. And we will be referring to these phrases in the body of main.dsl. Data.json is super cool. So this is you providing data to train neural networks for recognizing user intents or for recognizing named entities, which can be used to identify variables and data points and store them as variables in the phrases that the user says to the AI. Alright, so let's get started. We'll start with main.dsl. The first thing you see, we're importing common reactions. So that's a library of commonly used phrases, words, etc., ways to react to situations. For example, I can't hear you, or are you a robot, or if the user swears, what do we do then? So the next block is the context variable block. First, we declare input variables. These are the variables that the app should expect to receive when the call is initiated. We're not going to have an input variable for name in this conversation because we will actually ask for the user to tell us their name. That's what we'll start with. And in addition to the name, we'll declare a couple of other variables. For example, we will be storing the policy number, so we need a variable for that. We will be converting the number to make it sound human readable by the AI, so let's create a variable for that. The thing is, all data collected from the user by our AI apps is stored as strings. And so if we store a string of numbers, the AI pronounces that number back as, for example, if it's 111, it will pronounce it as 111. But if we want to dictate the policy number back, we need to split up the various numbers in the string, and we need to join them back together with a space in between so that they sound like numbers and not like a single number. So policy status is another variable we will need to declare. And then we've got a couple more. We want to store the rating. We want to store open feedback. So basically how we're going to do this is we'll ask for feedback of 0 to 10 at the end of the conversation. If the feedback is 6 or below, then we will ask for a sort of more open feedback. What did you not like? What could be done better? And finally, we've got a variable claim, which refers to the status of the claim, which the user will be asking the AI to confirm. Now, the third block is the external function block. I already mentioned the external functions to you. This is the way in which we basically, I'm going to toggle word wrap here. It's the way in which we call up, so DSL, Dasha scripting language, is a domain-specific language based on TypeScript. It's got a very specific purpose, and that's designing conversations. It doesn't execute complex logic. It doesn't integrate with APIs. To do all that, we have to go back to the JavaScript file, server-side JavaScript file, index.js. So with the external functions, we can call up specified functions in the body of index.js code. So we need to define two functions. One is check policy. We're checking the insurance policy against some mock data. And two is convert policy. Okay, perfect. So now we are down to our starting node. So what happens here? As you can see, the structure, so a node is a single point in the conversation where the AI says something, the user replies something back. In theory, we can have a node where no conversation happens, where calculations happen, where external services get called up, and we will have a node like this in the body of this particular script, of this particular conversation. But let's look at start node root. So we start off by doing what? We connect to the phone and we wait for speech. It says 1000 milliseconds. Let's change it to 2000 milliseconds. Then in the example here that we've got, we say the phrase greeting with the variable name being passed to the phrase map to pronounce it. But as I have mentioned, we don't have a name as input variable here. So what we do need to do is we need to change this particular greeting to change it from, where is it? Change it from hi there name, can you hear me, to something like, for example, hi, hi, thanks for calling Acme Insurance. This is Dasha. I'll be your AI agent, or your artificially intelligent agent today. Can you please introduce yourself? So we're asking for their name, for the user's name. And so note this, we've got two phrases in the greeting. One is first, so this is the phrase that gets pronounced the first time we pop onto this node. The second time we get into this node, we want to pronounce a different phrase, otherwise it's going to sound ridiculous. So let's change it to, I was just saying, can you please introduce yourself? Good stuff, good stuff. All right, so we greeted the user and we're waiting for it, and we're waiting for their speech, and then we transition to the next node. But we're not really waiting for a yes/no response. What are we waiting for then? We're waiting for some specific data, and that data is the user's name. So on message has data name, we will want to make the transition to node 2. Now let's just call this transition node 2. So please note that this is the name of the transition, this is the name of the node. They don't have to be the same, but I like to keep them the same because it just makes it easier to keep up with sometimes. Other times it makes a lot of sense to change them. So we're waiting for the data name. Now that means we need to define this data. It needs to be defined in named entities, and I'm just going to go ahead and copy and paste it from the code that I have written previously, because that will be a lot of typing. Probably too much typing for my liking. All right, there we go. Oh, yeah. Makes sense. There we go. So the named entity is named name. Wow, very, very original. And we've got some values that we're defining. Dr. Phillips, Jim Smith, Tony Montana, Jill Jones, and includes. So take a look at this. You see open set true. This means that the AI can substitute any other values that make sense for these specific values. If it said false, then it would only look for these values. So includes, what are we including here? Let's add one more. This is a super cool thing that basically lets us tell the AI where in the body of the conversation to expect this data to be located. It doesn't have to be an exact match, and it will still pull the data out of these conversations if it's not an exact match, but it helps to define some potential ways in which this data can be placed in the user's response. So we've defined the data for the name. Now we need to create node 2. Let's go ahead and just replace this thing with node 2. In node 2, we are going to want to read the user's name back out to them. So to do that, we begin by setting a storage variable. So we've got the variable name defined as a global variable, and instead of saying message has data, we're saying message get data. Get this data here that we identified, and store it as the value of the local variable name. I like to always log any data that I store just to make sure that it was stored correctly. And then we say in the next phrase, which is going to be pleased meet. So pleased to meet you, such and such. See, it's highlighted because there isn't a macro with the name pleased to meet. What's a macro? A macro is used in the phrase map to map to specific points in the specific phrases rather that are used in the body of main.dsl. So here we define the macro for pleased meet. I deleted 2 macros for yes and no because we won't be using them. This was just some sample stuff in the sample app. And we need to add the text for the pleased to meet you phrase. So let's, if you remember the structure of the initial greeting, this is pretty much the same structure here. We're using, so on the first time we drop into this node, we're saying pleased to meet you such and such, how can I help you today? The second time, if we drop into this node, we say I was just saying how can I help you today, such and such, question mark. All right, so this is done and good, but we're not exiting. We're waiting for speech. And then we are going to, so we wait for speech, and we're not even specifying any transitions here specifically, because we're waiting for a digression, for the user to specify a digression. What are digressions? Digressions are amazing. Digressions are a way in which you basically can make your app human-like. You can teach your AI app to be prepared for all the different tangents that people send it on, and you can also use digressions as sort of a menu. So when we have the AI agent say, hey, how can I help you today? And then we wait for a digression. In this case, this is a simple demo app, so we really are waiting for the purposes of the demo on one single digression, which is, hey, I'd like to check some details with my insurance policy. We're actually going to define other digressions, but logically this is the one where everything begins. So let's create the digression. I'm going to call it policy 1, and and it becomes active on conditions, on the condition of the message has intent policy check. So as you can tell, we need to define this intent. We need to define the intent because we're calling out to it, and we define the intent again in the data.json file. So policy check, let's do this. So we say policy check, and it includes such things as like to check my insurance details. Maybe I'd like to I want to check my policy details. Can I check my policy details? And then some simple stuff. Policy details, insurance policy details. That should be good for us. So excludes are intents that we definitely don't want to register in case they come up. This is super helpful if you're running into false positives. If you're running into false positives, you want to add them to excludes. And so now that we have defined that intent, what do we do when this digression comes into play? We say a phrase, what policy? What policy do you want to check is precisely what we say. And then we wait. What's your policy number, rather? Something like that. We wait, and then we go into a transition from here. The transition will be to, well, let's call it policy 2, and it will mean we go to node policy 2 when the message, so we're asking what's your policy number, so what are we looking for? We're looking for data, aren't we? We're looking for message that has data of policy. Okay, so we're going to get to the node in a second. First, we need to define what policy in the phrase map. So what's this policy that what's this phrase that we pronounce out to the user? So again, I'm just going to copy and paste this in here. What policy? Can you please share the policy number you'd like to check? Or if we come back to the second time, let's try this again. What is your policy number? Okay, good stuff. So now we need to create node policy 2. Let's do this. Node policy to do. What do we do when we fall into this node? We have to, we don't have to, but we really do need to. We need to set the variable of policy number as equal to whatever data we got. Message get data policy. Oh, and we want to make sure that we're getting the first value in there. There we go. And then remember that we have to convert this number. So obviously once the AI heard the policy, it makes sense to read it back out to the user. So we want to convert this number to a not convert it so much as split up the string, split up each character in the string, and put a space between each character so that the AI can read it back out as a 111 versus 111 example. And we take the policy number, we send it to external function, and that result of whatever the function returns, we save it as policy read variable. So let's just finish typing this up here. So we will want to log policy read to make sure that we can keep track of it, and then we'll say something like confirm policy with the use of these variables. Yep. Yeah, no macro. We will fix that in just a second. Before we get to fixing that, let's look at the external function convert policy. So we are calling it up here, we've defined it here, and it needs to go in the body of index.js, in the body of the function that's running this app here. So let's add it. I'm going to copy and paste this code in here. Right after await app start. Right, so this is our external app. It's called convert policy. It accepts arguments. The argument it accepts in this case is policy number, and what it does is it splits up the policy number. This is JavaScript obviously, and then it joins it with a blank space and a comma. Console logs it, which is sort of redundant because we're going to console log it when in the body of main.dsl, but whatever, let's keep it, and returns policy read to to the node here. Returns it, and it gets saved as policy read variable. So then we say confirm policy. Let's go into the phrase map and add this phrase right here. There we go. Thanks. Let's make sure I got the number correctly. Read the number back out. Is this right? Okay, good stuff. Bye. No, not really bye, but how can I help? Is this right? And then we wait for a yes or a no. We are waiting for the user to give us either a yes or a no. So let's define these transitions. Transition named yes. Go to policy 3, the next node, on message has intent. Yes. Oh, mistake. Yes. Go to transition no. Go to node. We're gonna have to create an extra node where we ask you know, what's the number again? Let's try this again. What's the policy number? And that gets activated when the message has intent. No. All right, so message has intent, yes. Message has intent, no. Look at data.json. I've got the yeses and the nos predefined. You can check them. I had a very strange, very unlikely false positive on this particular phrase, so I edited it as excludes at a certain point. And this is not going to be relevant. So there you go. You can modify these, obviously. So now we need to create two nodes. Let's create policy 1A first. That's a repeat node, as you recall. If we get if the user says no, the policy number you read back out to me is all wrong, then we use this node here to say what's the policy number again. And we've got node policy 3, which actually progresses and moves our conversation forward. So if we land, when we rather land on node policy 3, we need to do a couple of things. We set policy status, external, check policy with the policy number as argument. What are we doing here? We're calling up another external function, as you can tell, and we are asking this external function to check the policy for us. Is it a valid policy? Is it an invalid policy? And to save that result as the policy status. So whatever gets returned from the external function, save it as policy status variable. So let's go ahead and look at how we are implementing this. When you build something like this for a real life app, obviously you will want to call up an external function here that then interacts with a database or whatnot, interacts with something and basically gives you real data to return to the conversation. In our case, we are just providing some mock data. So literally what we're doing is we're creating a random number, checking, you know, just basically tossing some dice and returning whether this is a valid policy number or this is an invalid policy number, and there is no active policy with this number. That's what this function here returns. So once that returns back, we will want to read the results back out to the user. And that we do by saying a phrase which sounds like verification result. We will read the policy status. Oh, sorry. We'll read the policy status variable back out to the user. And then we'll wait until the user confirms whether the result was correct or incorrect. Wait, sorry, give me just a sec. We're reading verification results, so yeah, okay, my bad. So verification results, we say, hey, looks like a valid policy, looks like an invalid policy. Is there anything else I can help you with? All right, so let's define verification results in the phrase map. Verification results, so again, we're saying, okay, let me see here. It looks like this is a valid policy number and there's an active claim associated with it, or it looks like there is no active policy with this number. Anything else I can help you with today? So we wait for a second for the user to reply, and then we transition. So the reply will either tell us yeah, you can help me with something, or in which case we go to node can help, where we basically say, how can I help you? And this gets activated on message has intent, yes please. Or we might have, oh, what the hell is going on here? Oh, yeah. Or we might have the user say no, in which case we go to a bye-bye and rate me please on message has intent no. Or we might get a digression, in which case we'll go to the digression. We're going to get to these digressions in just a second. So let's just define these nodes that we have to have. One of these is can help. So basically we're saying, hey, how can I help you? And we'll add that phrase to the phrase map a little bit later. Then we've got a node by rate. Well, you know what? Might as well go ahead and add it to the phrase map right now. Yep, there it is. Then what's the other node? By rate. Oh, it's a rating node. We're asking for a rating. How cool is that? So how does that node, what is it going to look like? Pretty simple. We say a phrase by rate, and then once we get the data rating, we transition to the rating evaluation node. That's actually going to be that node where no talking happens, but only processing of numbers. So what have we got here? By rate. Let's define by rate. There it is. By the way, you probably have noticed that I haven't been adding these macros here, which is, I guess, okay, because I'm just gonna copy and paste all of my macros in a little bit later. It's a good idea to keep these things going as you go along, but it's not going to let you forget about them. It's just gonna, throw errors the whole way through. Like here, for example, it's throwing an error because it can't find a name. What was it? Confirm policy. Yep. All right. So where were we? We were at by rate. So message has data rating. As you might have noticed in the data.json file, we have some data for rating as a holdover from a previous app, but it's a rating of 1 to 5. In our case, we are asking to be rated on the scale of 0 to 10. Thankfully, I've got this data set right here, and I'm just going to add it to our data.json file in a second. There we go. Please note that this data set is a closed data set, which means that if the rating is like 50, that's not going to get substituted for one of these numbers. All right, so we checked the rating, we got the rating, we got the data. Next we go to node rating evaluation. This one is pretty fun, I suppose. Here's how we do the evaluation. So we get this data here. We set it as the global variable rating, the first value of the set here, and we log the value of rating just to be on the safe side. Then we do one thing. So as you remember, all the data collected with data.json with named entities is stored as strings, so we need to convert this number to an integer. So we use the parseInt function to convert it to an integer, and then we evaluate. If the rating is greater than or equal to 7, then we go to rating positive. If it's less than 6, less than or equal to 6, obviously, then we go to rating negative. And these, when we say go to here in the body of do, we're referring to the transition. So rate positive transition takes us to the node rate positive. Rate negative transition takes us to the node rate negative. These are going to be some pretty simple nodes. So rate positive especially is very simple. So we'll say a single phrase and then we will exit the conversation. Thank you for such a high rating and thank you for your time. By the way, please note here, I wanted to show you this. I'm not using the say function to define something in the phrase map. I'm using the say text function, which actually means I have to type out the entire text right here, which is okay in a case like this, but generally you don't want to go into production using say text in the body of your app. Node rate negative. How is this thing going to look? So if we get a negative rating, we probably want to check, why was this person unhappy? What were they unhappy about? So we say rate negative, which in our case we're going to say, oh, you were pretty unhappy. Can you tell us what went wrong? Can you tell us what we can do better? So what is this phrase? Let's add it here. Just a second. I'm so sorry to hear that you did not enjoy the experience. Can you please tell me what you feel could have been done better? I think that is quite good. When we wait for the response, we're waiting for some data. But we're waiting on like literally anything that the user says. We want to get that entire phrase and save it as the data. So our transition happens here on true, which is a condition that basically tells Dasha AI, hey, whatever happens, just go and follow this transition. Whatever the user says, follow this transition. So as we exit the node, here's where we're using the on exit thing. As we exit the node, we do the following. As we exit the node on this transition, we do the following. We don't say anything. We just set the storage, global storage variable feedback as equal to whatever text the user pronounced back to us, and we log this feedback just to be on the safe side. All right, so that's our rate negative, and I think okay, and we go to neg by from here, which is pretty much same as rate positive by. We're saying thanks for sharing. Thanks for sharing. Thank you for your time. Call back if you have any more questions. Bye. Perfect. So what happens now? We've got sort of the body of the conversation, but the user may want to ask a few more things. For example, they may want to ask what their claim status is. They may want to ask the AI app, how are you? And we want to account for all of these things. They may want to ask whether they have accident average, accident coverage. They may want to redeem their claim, and they may want to refund it, or they may want to just say bye to everything and everyone. So let's look at these digressions that we've got here. So the first digression I added is how are you? We're saying, hey, how are you? How's it going? The AI replies, I'm well, thank you. And here we're using a little something to basically tell the app to go back to the node from which the digression was called. And when it goes back to the node, as you recall, if we visit a node a second time, we don't say the same phrase, we say a different phrase. That's defined in the phrase map. We may have a digression for accident coverage where the user says, hey, do I have accident coverage? And we say, hey, oh, hold on, sorry, you feel this way, let me transfer you. Yeah, we need to change this to say, yes, it seems this policy has accident coverage, whatever that means. And then anything else I can help you with. There we go. That's better. No, that's bad. That's better. All right. So interesting digression. Claim status. So if the message has intent, what's the status of my claim? We want to tell the user what their claim status is. So the first thing we do is, and this is kind of, we're doing the same kind of random calculations, but in the body of DSL. If the random number is greater than 0.45, we set claim as the claim is slotted to be approved tomorrow. If it's less, we set the claim as the claim has been approved. So, and then we say the phrase from the phrase map claim status, where we use the variable claim, which has been defined here, and ask, hey, anything else we can help you with. Then we try to redeem the claim. We say, hey, would you like to, if the user says, I'd like to redeem my claim, then we tell them basically, yeah, your claim is good to go. Then we ask them within this. So let me just show you the phrase maps for all of these things. So yeah, let's look at all the phrases here. So for the claim status, redeem claim, this is what the phrases look like. Claim status. It looks like your claim status. It looks like your claim is slotted to be approved tomorrow, for example. You can redeem it if you like. Is there anything else I can help you with today? And then if we say yes, we go to the node can help, which is basically asking, how can I help you? If we don't, we go to node buy rate, which we've gone over already. You can redeem this claim if you like. Anything else I can help you with today? Yes, I'd like to redeem my claim. We've got the data right here for that. Intent data. I'd like to redeem my claim. Yes, I'd like to redeem my claim. So the AI tells the user, absolutely, it looks like there's a bank account tied to your account with us. Would you like to go ahead and sign off, and we can redeem and process the refund when we get around to it? The user says yes, so we tell them, great, refund process initiated, anything else I can help you with? If the user says no, then we go to buy rate and we do the whole rating workflow. And there we go. I think, I may be wrong, but I think it looks like we've got everything that we need to in here. So let's go ahead and run npm I. Good, good, good. And let's try a test chat to start us off. I usually test with the chat first before starting to test with voice. Now, see here what's happening. We're training custom intent. The neural network starts training with the data that we provided to it in data.json. This can take anywhere from 30 seconds to 5 minutes, maybe even a little bit longer. So I'm going to pause and I will come back to you guys when the intents are trained.
For calling Acme Insurance Claims Helpline. My name is Dasha. I will be your artificially intelligent agent today. Can you please introduce yourself?
Hi, my name is Jon Snow.
Pleased to meet you, Jon Snow. How can I help you today?
I'd like to check my insurance policy details.
Can you please share the policy number you'd like to check?
718714.
Thank you. Let's make sure I got the number correctly. 718714. Is this right?
That's right.
Okay, let me see here. It looks like there is no active policy
we try another policy?
Can you please share the policy number you'd like to check?
2221337.
Thank you. Let's make sure I got the number correctly. 2221337. Is this right?
Yeah, that's right.
Okay, let me see here. It looks like there is no active policy with this number. I'm sorry. Is there anything else I can help you with today?
Yeah, can we try a different policy?
Can you please share the policy number you'd like to check?
Hold on for just a second.
Okay, I'll wait.
Okay, it's 8675309.
Thank you. Let's make sure I got the number correctly. 8675309. Is this right?
Yes, that's right.
Okay, let me see here. It looks like this is a valid policy number, and there is currently one active claim associated with this policy number. Is there anything else I can help you with today?
What's the claim status?
It looks like the claim has been approved. You can redeem it if you like. Is there anything else I can help you with today?
Yeah, go ahead and redeem it.
Absolutely. It looks like there is a bank account tied to your account with us, which is enough we will refund the claim value to your account.
Yeah.
Would you like me to initiate this process?
Yeah.
Great. Refund process initiated. You should receive your money in 3 to 5 days. Anything else I can help you with?
Nope.
I'm glad I could be of help. How would you rate our interaction on a scale of 0 to 10?
8.
Sorry, the connection dropped for a second. Could you say that again?
8.
Thank you for such a high rating and thank you for your time. Please call back if you have any more questions. Bye.
Bye. So there you go. So what I want to draw your attention to is that while I have some names defined in the data set that is used to train the neural network, giving you the AI as a service component, I don't have the name Jon Snow here, but I do have instructions on where such a name might be located, so it was identified. Same goes for the policy numbers. The first one is nowhere to be found here. And the same goes for the intents that I used to transition between the nodes in the conversation. They're similar, but not exact to what is listed here. So if you like this, like I said, the source code, the tutorial and the source code are in the links to the description. There's a link to our community. Please join. We'll love to have you. And start building with Dasha. Thanks a lot. Tune in for more. Bye.